How does risk assessment fit into mechanical design? Have you ever wondered how engineers ensure that their designs are not only innovative but also safe? Today, we will explore the role of risk assessment in mechanical design. This process is vital for creating reliable and compliant mechanical systems. Risk assessment starts with identifying potential hazards. This means recognizing anything that could cause harm during the life cycle of a mechanical system. Hazards can arise during design, manufacturing, operation, or maintenance. They can be mechanical, such as crushing or cutting, electrical like shock or fire, thermal issues like burns, or even noise and vibration problems. Environmental factors also play a role in this identification process. Once we have identified these hazards, the next step is risk estimation. This involves evaluating how severe the consequences of each hazard could be and how likely these consequences are to occur. Engineers often use risk matrices to prioritize these risks based on their severity and probability. This helps in understanding which risks need immediate attention. Following risk estimation, we move to risk evaluation. Here, engineers determine if the identified risks are acceptable or if they need to be reduced. If a risk is deemed too high, designers will implement protective measures. These can include safety features like guards, emergency stops, or interlocks. Redundancies, such as backup systems, may also be added to eliminate hazards or lower risk levels. Incorporating risk assessment early in the mechanical design process is essential. It helps engineers create safer and more reliable products that comply with safety standards and regulations. This approach also supports ergonomic designs that minimize human error, making systems easier and safer to use. Practical applications of risk assessment in mechanical design are numerous. For instance, defining the limits of machinery is crucial. Engineers must consider both the intended use and any foreseeable misuse. Structured methods such as failure modes and effects analysis, hazard and operability studies, and fault tree analysis are commonly used to analyze potential failure points and hazards. Documentation of the risk assessment process is also important. It demonstrates compliance with standards such as International Organization for Standardization 100-2100 and machinery directives. As designs evolve, it is necessary to reassess risks to ensure that new hazards are identified and managed effectively. Understanding risk assessment is fundamental for mechanical engineers. It bridges the gap between creative design and practical implementation. This process ensures that engineers not only innovate but also deliver designs that protect users, operators, and the environment while meeting legal and industry requirements. It is a vital part of the overall engineering design workflow and is critical for successful product development.